Uh, Hello, everyone. Good afternoon from Europe, and good morning to our colleagues in Canada. We are going to have we want to welcome you to this session of EU-Canada Week on ICT Standardization, focus on quantum technologies and post-quantum cryptography. Next slide, please. A few things about the process. This webinar is recorded, and also if you want to ask something, please use the Q&A function at the bottom of your screen. Please, we would like to ask you to include your organization to help us during the Q&A process. Next slide, please. Okay, my name is Papadopoulos Homer. I'm coming from NCSR Dimoktos. I'm research director there, and I'm also co-founder of a spin-off company, Synthesis. I'm also leading the Quantum Task Force in INSTAR project, and also I'm leading the Greek delegation in Sensenelec in JTC 22, and now we're going to lead the Greek delegation in ISO-IC JTC 3. Before going to present you the first presenter, I want to tell you that it's my pleasure and my honor to moderate today's discussion, bringing together experts from both sides of the Atlantic in order to discuss about quantum technologies and quantum communication technologies and how we can make these technologies more secure, utilizing tools like standards. The dialogue we are going to have is not only focusing on standards, but we intend to highlight the challenges and the opportunities that we share, EU and Canada, and discuss some open collaboration and trusted innovation in this domain. Next slide, please. Next slide, please. I just want to describe a few things about INSTAR. What is INSTAR? INSTAR is a project, an EU-funded project, where the mission of the project is to build active partnerships and communities of stakeholders between across like-minded partners in EU and other areas of world like APAC and North America. Our aim is to develop common vision and priorities and priority lists in order to promote standardization in the ICT domain. We also want to facilitate cooperation and active collaboration on common priorities, like this event is a tool that facilitates this aim. Also, we intend to support the implementation of the digital partnership with common standards. Next slide, please. In INSTAR, we have 6 domains. We have AI, data, cybersecurity, IoT and edge, 5G and quantum. We have created 6 task forces with experts, and we created some priorities, some priority lists in the standard domain for these 6 domains. Also, we are in contact with international partners to match this priority list with their priority list in order to identify joint initiatives, joint interest, and promote this interest in the international SDOs. Next slide, please. The next event from INSTAR, where you can join, is the Global ICT Standards Conference that will be conducted in Seoul, 3 to 5 of November, and the IEEE communication standardization activities that it will be online and you can register and attend. Next slide, please. Now we are having the 3rd day of this forum of the quantum and the PQC events, and I'm happy to introduce our next panelist, our next speaker. This is the agenda. You can find this agenda in our site. And now the floor is open to Fabiana, the PEV, Program Manager at Emerging and Disruptive Technologies at the European Commission. Fabiana, the floor is yours. Give us a short introduction of yourself and please go on. Thank you.
Yes, thank you very much, Omar, for the introduction. Indeed, my name is Fabiana, and I work in the Directorate General Connect at the European Commission, and I work in particular on designing policy initiatives, but also the strategy for the very future activities for both quantum communications and post-quantum cryptography. So I would like to start a bit with an introduction about how the activities here are organized. So next slide, about quantum technologies. So we have some strategic pillars that try to move the very research, let's say, stage activities towards deployments and infrastructure. And for this, we mostly use two main programs: Horizon Europe for more research-based activities, and Digital Europe program, but also other programs like Connecting Europe Facilities and Iris Square, the secure connectivity program, more for deployment and future infrastructure. So the quantum flagship, that is more research-based, funds research in quantum computers, in quantum sensors, but also in specific technologies for quantum communications, for example. And we also take care, of course, on advances in digital skills. So to build the next generation task force for quantum technology, not only via the quantum flagship per se, but also via other pillars of Horizon Europe, that is a very large research and innovation European program. Towards infrastructures, we are deploying actually, so we are not only doing experiments, but we are really building systems and scaling them up to build a quantum communication backbone all over Europe, that for the moment we see it mostly implemented in QKD, but in the future it will support also protocols that will allow for more cryptographic functions apart from key agreement, but also other functions like distributed computing. We also have activities on the to bolster the European competitiveness in quantum chips and in implementing production facilities, and also, of course, on high-performance computers with accelerator and standalone quantum computer, but also building, let's say, the initial stage for classical quantum hybrid networks. So next slide, please. So, well, as you probably know, at the beginning of July, we published a quantum strategy. This is is an action in the context of the fact that the global race for quantum technologies is heating up. We have in Europe a robust research base, but overall there are some fragilities in the ecosystem, because often indeed some solutions are not scaled up sufficiently quickly. We also have the complexity coming from the fact that we have 27 member states. And of course, we also are under pressure in order to ensure our sovereignty in future quantum and digital technologies in general. So the quantum strategy that was published in July is focused on 5 main pillars. Of course, research and infrastructure first, research and innovation first, then quantum infrastructure, so really to connect all the labs and building on scaling up the capabilities of each single entities. We have another pillar, which is the quantum ecosystem, so all the actors that have to be moved together. We have also a focus on dual use, in particular for those technologies that are so-called dual use, and of course also a focus on strengthening the skills for quantum technologies. So Europe we aim at becoming a quantum industrial powerhouse based on the excellence of our research and on our capability to scale up all the precious expertise and knowledge that we have in Europe, and in order to deliver sovereign and trusted solutions for EU citizens and their security. So next slide, please. So the first area is research and innovation. The key components are, of course, foundational research and innovation in quantum computing, communication and sensing, but we also have actions that are focused on moving from lab to fabrication, so investments in infrastructures, pilot line, hardware and enabling technology, and of course apply and use. It means to accelerate the development of applications. The implementation of this will be, let's say, based on the creation of a body which will be a joint undertaking established under a mandate of the European Commission, which will have its basis in the Euro High Performance Computing JU, but will make it evolve. And it will also be supported by a Quantum Act for which the proposal is due in 2026. So for the next slide, area 2, we have Quantum Europe infrastructures that indeed are focused in the three main areas of quantum computing and simulation, quantum communication and quantum sensing. And there are particular specific objectives that have been set in this quantum strategy at which we aim at reach at specific dates or specific intervals of time, let's say. For example, okay, initiate immediately, we already have it, but scale it up more. Hybrid HPC quantum platforms, reach fault-tolerant machines with 1,000 plus qubits by 2030, 2035. We have the plan to issue a roadmap and benchmarking tools, of course, and we have set up specific milestones for quantum computing and simulations. For quantum communication, much is already ongoing, but we still have much to do to connect the deployments that have been done previously in individual member states, and also to design the space segment that will allow to overcome the limitation distances, the current limitation distances for limited distances for QKD. And for quantum sensing, yes, we are much interested in gravimeters, but also especially for applications in the health domain, where quantum sensors can really give advantages in the accuracy of their measurements. So next slide, please. So yes, well, for the international cooperation standards, you know that we collaborate with several trusted partners, Canada, of course, Japan, US, South Korea, and our focus, our main interest is indeed on the interoperability and standard settings, and aligning bilaterally the roadmap, and indeed keep each other informed via joint workshops. So for what concerns, let's say, strategic autonomy and sovereign capability, of course, we have EU-led pilot lines, foundries, and secure communications infrastructure, but it is also true that Canada is also part of several of our projects. So we are really happy about these collaborations, and we think indeed that this trust in partnership for making quantum technology evolve for the benefits not only of of specific niche cases, but in the long term for all, for as many as applications as possible, is a fundamental basis for this collaboration. And of course, for what concerns standards, we are active in several groups, and we are also much focused, especially in this period, in giving emphasis on ethical frameworks related to the development of some specific standards. So yes, next slide, please. So I would like to mention something about quantum safe cryptography, QKD, and quantum resistant cryptography, post-quantum cryptography. So for what concerns QKD, so can you, yeah, the next slide, please. So here I will go very fast because I think you already know, but we have the EuroQCI terrestrial segment, that is the segment for the deployment of the European quantum communication infrastructure that for now it sees its implementation in quantum key distribution. We have 26 national projects, plus 6 industrial projects, plus we have a very important projects related to attack QKD devices and test the robustness of protocols and implementations. We have just finished the evaluations for other additional projects that will interconnect different member states, and we have some calls that are already inserted in the secure connectivity program, which is the next step of advances in this terrestrial segment. So next slide, please. For what concerns the space segment, yes, we will have the first satellite demonstrator launched next year, hopefully December 2026, for QKD prepare and measure. It will be a proof of concept, and it will test interfaces with the optical ground station. And then we have the plan to develop a first generation of satellites that will be based on EU technology, and that will be possible also available to more and more member states. And it will allow the exchange of keys between different sites on EU continental territory. And in the future, in a second generation, we will have a full coverage of users, but also we will have an increase in the security guarantee, not only for the advances of research, but also because they will be imposed. So the research will have to advance. So thank you. Next slide. So yeah, as you know, as you probably know, we are active at several standardization bodies, European and international, European Sensenelec JTC 22, especially the working group 4 on quantum communication and quantum cryptography. We have the ETSI Technical Committee Cyber and the ETSI Industrial Specification Group for quantum key distribution. Both of them are a recipient of several EU grants, but also at international level, ISO JTC 3 quantum technology. I also would like to highlight that there are also important national efforts, and one project that I like very much is a German project called Squad that indeed has identified many gaps in the standardization path that needs to be addressed. So here I put the link, and you are welcome to check it. And the next slide. So yeah, the vision for the future is that for the moment we are building really the foundational layer of what in the future will be an evolution of the network towards functions that are also beyond QKD, and that will be possible across multiple nodes, and will also allow classical networks to be enhanced with quantum capabilities, like for example distributed quantum sensing. strong. Of course, we will see a switch, a smooth switch, probably from the prepare and measure protocols to entangled photons, because this will allow more functionalities beyond the sole key agreement. And the ultimate goal of the quantum strategy is the quantum internet, where indeed we will have a global entanglement fabric that will connect quantum devices, labs, data centers, and time distribution facilities. So it's an exciting, but yeah, also very long-term path. And the next slide, please. So for indeed, let's say a more short-term, mid-term solution for what concerns, I am only talking about security here. Of course, we identify post-quantum cryptography as the most promising solution that can be implemented now, that can cover much more than key agreement, of course, and on which our society, which is public key cryptography, and on which our society is much dependent on. So yes, we see this as a really promising solution for the short and mid-term. Recently, in 2024, we have issued a recommendation to our member states to come together and issue a roadmap. This roadmap has been issued in June 2025 and establishes some milestones that are recommended for all member states, in particular to establish a transition plans by the end of 2026. Then by the end of 2030, high-risk use cases must be migrated, and also quantum resistant software and firmware upgrades will have to be enabled by default, and also planning for the migration of medium risk cases will have to be done. And in principle, we should be migrated by the end of 2035. In a very optimistic view. So the next slide is, yes, we have, as Europeans, we have an outstanding contribution to standardization activities, in particular NIST competitions. Here you see the first two competitions for key agreement and digital signatures, and you can see how the candidate algorithms have a strong contribution from Europe. So also for this, indeed, the additional call, so the on-ramp call for digital signature, which is in the next slide, please. Also for this, we have again an outstanding EU contribution for diversifying the portfolio of digital signatures that are even more, allow me to say, a sort of bottleneck compared to key agreement. So you can see that we have many countries that are many of our universities, research institutes, but yes, also companies, spin-off that are contributing to the submission of algorithms and to submitted algorithms. So yes, if you can. So there will be a new NIST competition for multi-party applications, and these also our researchers are already working on them. So we expect again much contribution from EU, in particular about fully homomorphic encryption and zero knowledge proofs that are fundamental for privacy enhancing technologies and that are extremely important for for the European policy framework, for example, in digital identities or protection of certain vulnerable class of people. So next slide. The standardization activities, again, are many at different level, not only NIST, but also at ISO ESC, but also at IETF and IRTF. So for ISO IEC, for example, the standardization of CHEM also implies the standardization of FRODO-CHEM that is supported by France and Germany, classic McElise supported much by the Netherlands and eventually by Germany, and of course also the already standardized MLChem, so the one that was Kyber to be inserted into protocols, but there is also a lot of PQC activities in IETF, IRTF for many protocols that support core functions over the internet, but not only over the internet. They may have also other use cases. So yes, I think this was my last slide, and thank you very much for your attention, and I'm open to any comment.
Thank you very much for the presentation. Very impressive what you are doing. Since there are no questions at the moment, I can ask you. My understanding from your presentation is that at the moment you are prioritizing PQC compared to QKD, at least in to support real-life implementations. Is this a correct impression, or you try to balance between the two?
Let's say it is good to continue the investments in QKD because this is a long-term investment, and of course, at a certain point of time, it will surely pay off. Of course, there are let's say the urgency to move to migrate to PQC is increasing, and this is not only because of the developments of improved error correction methods or improved optimization of quantum algorithms, but because in 2030 there will be the deprecation of already of some implementations of current public key cryptographic algorithms. So yes, we have to accept that we need to migrate, and this has really a practical consequence. However, there is also a very fundamental fact that symmetric cryptography is very robust, and so we cannot exclude at the moment that in the future, actually, we may have to rely more and more on it. And I'm not even talking only about QKD. It could be a combination of several symmetric solutions. Yes, the trajectories of all these technologies are different, and we cannot exclude any of them. I think that we need to be open. We also need to recall the fact that several PQC algorithms have been broken, and several of them, I'm sure, will be broken in the future, also by classical computers. So on the other hand, we have to realize that for scalability, QKD has still some important challenges when you move out from the lab to real-world implementations. So all these are fields where we need to invest, and yeah, we will not let any of them down. Of course, for PQC, because it is urgent, also the member states, they will have to move themselves and reserve budget in their migration plan, because Europe will not be able to constantly release money on that, because there are many, many challenges to be funded in all fields.
It's clear. The urgency of the issue is very clear to us. Okay. We have a question from Michelle Mosca, please. Michelle?
Yeah, thank you. Can you hear me okay?
Yes, sure.
Yeah, thanks very much, Fabiana. That was excellent. And I just want to follow up on the last remark you made, which I totally agree with. Because sometimes when we say PQC, we can mean different things. We can mean the fundamental algorithmics, which of course on their own are not helpful. They have to be deployed in some kind of deployable infrastructure. And often we mean public key infrastructure. And usually we mean public key infrastructure, which has both certificate chains for authentication and then key exchange. So two separate but important functionality. And sometimes by PQC, we simply mean stuff that doesn't need a quantum network, right? It's classical. You can deploy it on any device. And that includes the symmetric key methods you highlighted. And I mean, 10, 15 years ago, I was like, don't bother, don't distract me with the symmetric key stuff, but I realized in the last few years that I think there is some important wisdom in what you were saying and what the cryptologic authorities were telling me 10, 15 years ago. So I would urge us to think about how we can both leverage post-quantum algorithms in symmetric key infrastructures and also deploy post-quantum algorithms and get your PQC compliance through symmetric key infrastructures. And then if we take this step back in a slightly broader view, so I think Einstein said you should make things as simple as possible, but no simpler. So if we simplify a little less and just think about the public key infrastructures, the different symmetric key infrastructures, then the role of QKD and quantum networks, which just keep getting better in terms of their functionality, is a lot clearer and not really controversial and really exciting. So anyway, I really appreciated the way you framed things. I mean, I'll talk a bit more about this in my remarks, so I'll stop now.
Michelle, in your talk, please also tell us about the approach Canada is going to take compared to PQC and QKD and what exactly is going to happen in the next years in your area. So this will help us to identify commonalities between the two areas. Okay.
Thank you, Michele.
That's it.
Thank you, Fabiana. Thanks for the presentation. If there will be questions afterwards, we will send them to you by email, or if you will join this event, we will we will ask you to answer to these questions. Thank you very much.
Thanks to you.
Excellent presentation. Thank you. So the next presentation has to do with EU priorities. We will try to discuss about EU priorities and the best practices, trying to showcase some real-world standards adoption. And in that case, we are having together with us Vicente Martin, who is going to give us a presentation about Sensenelec activities, because he's convener in Working Group 4 in JTC 22 in quantum communications. And not only that, and then we will have together with us Norbert Lutkenhaus, who will give us ETSI, the ETSI approach, and some information about activities there. Vicente, the floor is yours. Tell us a few things about you, and looking forward for the presentation. Thank you very much.
Thank you very much for the invitation. I don't know if I can share my slides.
Yes.
Or you will present it. Okay. No, well, apparently sharing is turning off.
It's off. I can
Now, yeah.
Now it's possible. Now it's
Okay.
possible.
Okay.
Okay. So can you see the slides?
Yes, if you.
Okay.
Okay.
Okay, thank you very much. So I'm just getting rid of all this, all the windows that I have in.
Okay. You can.
Yeah. No, the problem is
Slideshow.
I cannot reach the bar behind because it is
Okay.
taken over by some.
Okay.
So okay. So
Let's move on. Okay.
If this is okay, let's give you. Let me see. Is it working?
Yes, I can see the present. You can see the presentation.
Okay. Well,
Okay.
if it is okay, I will go ahead. So as you said, I'm the convener of Work Group 4 in JTC 22. JTC 22 is the Joint Technical Committee on Quantum Technologies from CEN, and it deals with several with all items that are quantum. I also work in ETSI, the ISG QKD, which is the thing that Norbert will be speaking later. So the first thing that I wanted to show you is just a general map of all these standardization entities. I mean, you can see that in the bottom you have the companies, the organizations that are interested in having standards, and they go to the national standard organizations. They then incorporate in European or regional level organizations, and then you go to the international ones. The way they work is slightly different from one to the other, but in the end they have very strict agreements about which one is going to deal with which, and which one say inherits the standards from the other, etc. It's interesting to see that there are maybe two main ways to participate in this kind of standardization. One way is go to standards or SDOs, standard defined organizations that are say mostly driven by industry, and others that are mostly driven by states. The ones that are driven by states, that means that you have to go to your national standards organization, and then is the national standard organization the one that allows you to go to this say state-driven organizations. The others that are more on the side of the industry, I mean, basically you go directly to those standard SDOs, and then you can participate directly. SEM belongs more to the state-owned ones, so the voting rights are on the state members, and if you want to participate in SEN, then you have to go to your national standard organization, and they are the ones that allow you to go to SEN. And of course, SEN and SENELEC has different agreements with ISO and IEC in order to determine, I mean, how the standards are applied in different regions. Okay. So in Europe, what the things that we are doing in quantum technologies are mostly around the ETSI and CEN. And CEN is this JTC 22, this Joint Technical Committee on Quantum Technologies, that deals about, say, all quantum things. I mean, in principle, we deal about quantum computing, quantum sensing, quantum communications. So in principle, it's all quantum. I will speak about quantum communications because this is the thing that I know of. And then the other side is the European Telecommunication Standards Institute, and in particular the Quantum Industry Specification Group. And quite recently, a new body, which is a technical committee, will be kicked off in a couple of months from now. But this is the thing that Norbert is going to speak about later. So just to give you an idea of how the quantum standardization world has progressed over time, this is the SDO's activities centered in quantum communications. And as you can see, I mean, the first one was precisely in ETSI, the ISGQKD, that started in 2008. Since that time till 2016, that we have the IEEE Standard Association that started a group that was called the P1913 on software-defined networking. That was the next one, and then we have, I mean, you can see we have a lot of standards defined organization preparing groups in around 2019, in particular ITUT and ISO IEC. The IRTF started the Quantum Internet Research Group also. And then in 2020, it was CENELEC again that started a focus group on quantum technologies that in the final, finally gave birth to this JTC 22 that we are speaking about. And later on, I mean, this year, well, on 2024, we have the ISO preparing the JTC3, which also on quantum technologies, and this year it was proposed the technical committee on quantum in ETSI, and the kickoff will be this next December. Okay, so this is more or less the panorama, and concentrating on sense, and started the focus group, as I said. And the focus group basically was just an exploratory. I mean, the focus group is just the mechanism that several SDOs, in this particular case it was CEN, to see if there is something that we have to do with some particular technology. And then they met a lot of experts. You can see we have about 200 experts. We spent, say, 2 years, almost 3. We have many meetings, and then in the end, we prepared a roadmap. We prepared several documents, and in the end, we finished with the need of having a JTC, a Joint Technical Committee, which is the committee that actually can provide the standards. which is the Joint Technical Committee 22 on quantum technologies. You can see the documents, the different documents that are public. You can see them in this web site that I'm pointing there, or using the QR codes. The last one actually was an update of an standardization roadmap on quantum technologies that was updated this last summer. The JTC, as I said, is worrying about everything quantum. I mean, it's quantum metrology, sensing, handset imaging. This is the work group 2. Then there is the quantum computing and simulation group, which is the work group 3. And then the quantum communications and quantum cryptography, which is the work group 4. There is also a strategy group, which is the work group 1. And as you can see, the objective of JTC is consider the adoption and contribution of international standards, and also deal with harmonization with other organizations. Like in this case, I mentioned JTC1 because at that point in time when we started, it was JTC1 the one that had all the things that were quantum in the ISO IEC. So the way to participate, I mean, you can see here how it is, how the JTC is created. I mean, we have the 4 work groups, and we have the national mirror committees, which are kind of the national branches of this JTC. And if you want to participate, basically you go to the national mirror committee, you say you want to participate in this JTC 22, and then you can go to this JTC. We had up to now 10 meetings. Next meeting will be late October here in Madrid. And if you are not from the European zone, I mean, you are not one of the countries that are included in CEN, you can also participate because there is some figure, I mean, in order to make standards broader and guarantee that standards can be adopted in different countries, etc. CEN has this figure that is called the Companion Standardization Body, and in particular, the Canada the Canada SDO is one of these CSBs, so they can actually send people to the CEN JTC 22, for example, in this case. So there are mechanisms to cooperate. And then just to take a closer look at what we are doing in JTC 22, as I said, we have the work group 1, which is the work group on strategy, is the one that actually has released the roadmaps. Then we have a work group 2 on quantum metrology, which, I mean, as you can see, this is a little bit transversal group in the sense that it provides technology to all the rest of the work group. So it's fundamental technologies. In particular, for example, I highlight here the proposal for entangled photon pairs and single photon sources, which is something that is very interesting also to work group 4 on quantum communications. And then there is this work group 3 on quantum computing and simulation. I mean, as you can see that there are several types of documents that we can develop. One of those type of documents are technical reports, but there are also technical specifications that in the end, if they get approved in the upper layer board, they can become, say, European standards that have to be adopted by the SDOs that pertain to CEN. Okay. Regarding the detail of the JTC 22 on work group 4 on quantum technologies, as you can see, the scope, the main scope is quantum communication and quantum cryptography. So it's say everything that has to do mostly with quantum cryptography and also expanding to quantum communications. We have up to now 5 work items that are running right now, and 1 that is in preparation, and we expect to kick off soon. I divided them in a little bit arbitrarily in different types. I mean, we have a couple of them on networks. We have another another 2 on security, because one is about gap analysis, and then we have this gap analysis about the standards, about satellites, and about security. I mean, note that since there are so many SDOs working right now, I mean, one of the things that we have to be careful is to harmonize the different standards and be careful not to produce standards that are, say, conflicting with others. Standards are things that try to promote a market and to promote, say, a global understanding of some technology and global usage of some technology. So it's better to be careful about harmonizing the different standards. And the one that is in preparation is a technical specification, which is about the technicals to characterize and calibrate optical modine detectors. That you can see it has also a leg, so to speak, in work group 2. And this is important for us in principle because it's important for, in this case, continuous variables quantum key distribution. So in detail, I mean, for example, we have, I mean, it was, Fabiana was speaking about quantum and post-quantum. We have here a technical report on quantum key distribution, post-quantum cryptography, and equitable analysis. That the idea is just to make an unbiased comparison of QKD and PQC technologies. I mean, we see that there's much misunderstanding of what is one, what is the other, when to use one, when to use the other, what is good for one technology is good for, what the other is good for. What is the state of each of the technologies, and this is the idea of this technical report, is to disentangle a little bit this conundrum. Then we have these gaps in IT security evaluation of QKD systems and networks. That is basically, I mean, you know, in the end, the objective here is to have a common criteria certification, and common criteria certification are long procedures that require lots of documents, lots of specifications, and here the idea is to create a map of what is still needed. Actually, some of these documents actually started to be prepared in the ETSI, for example, and some others are still missing. And here is just a map about what is still missing for that. Then we have more on the side of networks. We have quantum networks best practice, which is actually led by Homer. And the idea of this quantum networks practice is analyze what we know about network, in particular the networks that are being built as part of the national QCIs in Europe, and understand where are the bottlenecks of scalability, the interoperability, see what are the good parts and the bad parts, so that we can, say, highlight the strengths and know what are the weaknesses, and have some good lessons learned in just one technical report here. Then we have these design aspects of quantum communication networks. This is actually has not started. It was approved, but it has not started. And the idea of this technical report is again to take forward-looking of what is going to be future quantum networks, and how to make sure that the current quantum networks are going to converge to future quantum networks, and study this idea. But as I said, this has just been approved, but not really started. Then we have the gaps and roadmaps. We have this roadmap for quantum communication technologies in space. We believe it's also important in view that we are going to have several satellites in space, and of course we want them to be compatible, and we want them to have technologies that can be reused from one to the other, etc. So the idea of this roadmap is just actually to study what is the state of the art in quantum communication in space. See what is the general architecture, see what are the main things that we will need to standardize, decide which are the most, the ones that we have to give more priority, and the ones that we can maybe leave for later, because you know that making standards is usually a long procedure. So we need to start soon, and start for those that are the most important ones. And the idea of this roadmap is actually to determine which are the most important ones that we have to get ready as soon as possible. Then we have this gap analysis on current quantum communication and quantum cryptography standards, which is basically to take a look at the many organizations that are doing standard for quantum communication, in particular for quantum cryptography, and see what is still missing, and try to also to harmonize what we have to do in the future for having, say, a full set of quantum communication and quantum cryptography standards. And then lastly, we have this last proposal, which is the characterization of and calibration of optical homodyne detectors that, as you see, is about components. So it has as well, it has some contact with rope 2. And the idea here is just to characterize all these optical homodyne detectors because they are needed for continuous variables quantum technologies, in particular QKD and quantum random number generators. So we need to standardize the way in which we characterize and calibrate these detectors. And this is the short wrap up of the work group 4.
Thank you, Vicente. Thanks very much for the presentation of what is happening in Sensenelec. Since that at the moment we don't have any question, I just want to ask a short question. What we understand at the moment, of course, it's a new group, the JTC 22, is that it's a closed club, I mean, European-based, okay. Although you said you presented that there are methods for Canadian and other countries to participate, we haven't done that because again it's a new initiative. Okay, 3 years, 2 3 years. From the work items you presented, which of these, which one or two of these you believe would benefit the most from collaboration with Canadian, not, for example, not the best practice of EuroQCI. We don't need the Canadians to work on that, but which one needs more support from external entities?
Well, I will say, I mean, for the work groups, for the work items that are open, I think that security is one of the most needed. And in the end, you have to have, I mean, this common criterion, you have to have it accepted by everybody. And since this is something mandatory in the case of QED, I mean, you are not going to put, say, in service a system that is not really certified. So it also connects also with this Nostradamus project that Fabiana was mentioning previously about certification. So I think this is one of the most important issues. It's also recognized as such also in ETSI, so we will need to somehow synchronize. But again, this is a technical report, so it's basically something that is trying to determine what we need to have a good, say, certification pipeline for all, say, quantum communications products. In this particular case, I mean, the most mature is obviously QKD, and they are for security. So those are the ones that need the first certifications.
Okay, thank you. We have one question. Have you considered the role of various PSK schemes and how they might complement and compete with QKD and PQC strategies? I'm not sure if you can answer that.
Not sure. Europe?
No, it's a question in the Q&A.
I can.
Can you access? Yes.
Mm,
Maybe.
Is this from Fabiana?
No, I'm not sure. It's from a number. I don't. If the one who had the question can tell us her name, it would help. Can you access? It's Rainer Irasco. Okay. Rainer, do you want to ask your question in order to clarify what exactly you want to ask? Can you open your microphone? No. So can you access the question, Vicente? Or maybe you can answer
But I don't.
the question via email. I mean,
Can
through
you
the
repeat?
chat. Yeah.
Can you repeat?
Have you considered the role of various PSK schemes and how they might complement with QKD and PQC strategies?
Pre-shared keys schemes, you mean?
Yeah.
Yeah, well, pre-shared keys is something that, I mean, to some extent, is a way, for example, to kickstart a QKD communication. So it's something that you typically need. But anyway, I think that this maybe goes more in the direction of having symmetric key schemes mixed with all the systems that we have now. I mean, and I think that it's a very good idea. I mean, in the end, what we have to finish is with something that people call defense in depth, and defense in depth is just to have several layers of different cryptography that makes more difficult for an attacker to enter into your systems. And then you have to have, of course, you can have PQC, you can have even standard crypto, the crypto that we have now, which is certified, which is say well proven because it's time proven. We still don't have a cryptographically relevant quantum computer. And of course, we have symmetric key SKEs, I mean, symmetric key distribution schemes that can work well. So I think there is no need to dismiss any of those. What is true is that since all of our technology in the last years, well, last say, yeah, 30 years, have gone around public key, we are maybe too much used to the goods of public key. I mean, it's very comfortable to use. I mean, it's easy to use. But maybe we have to start to strengthen, at least in some areas, to strengthen that and add a little bit or a few layers more of security. And in that case, QKD is one possibility, and of course, using symmetric key distribution schemes is the other possibility.
I'm not sure. Maybe the work item of QKD and PQC, they are considering this kind of.
No,
No.
they are considering just PQC and just QKD.
Okay. Okay.
Distributed DSCs, I mean, it's something that they are not. It's possible because there was a suggestion that maybe we should include also a new work item to treat these things. But up to now, it has not, say, materialized. In any case, this is, I mean, the work group is, or the work group of the JTC is about quantum, so we have to compare with quantum, or at least.
Okay.
So making a technical report only just for that, I think that's maybe better in other places.
Okay. Vicente, there is a follow-up question, but because we don't have time, I will please I will put the question in the Q&A session or the chat, and please answer the question in chat. Okay, it's a follow-up of this question.
Okay, thank you.
Okay, thank you very much. Let's move to the next speaker, which is Norbert Lutithaus, the Vice Chair of ETSI QKD-ISG. We are looking forward for your presentation, Norbert, because ETSI QKD-ISG is maybe I can say a success story of standards in the quantum technologies domain, and looking forward. And please let us know also in your presentation how you, as coming from Canada, you are cooperating with European entities in this domain. Okay, thank you.
Okay, perfect, great. Thank you very much. That's very for the introduction. And so what I want to do today is indeed to present work from the ETSI ISG quantum key distribution. So to start out with, this is a project which is very clearly already EU-Canada, because indeed ETSI has many active members. It's an industry-based organization. So that means companies and organizations from all over the world can actually join and actively participate in that one. So if you look about our industry specification group over here, so it has QKD vendors in there, we have application vendors, telecom operators, we have government bodies and certification labs in there, metrology institutes, and as well academic experts. So that forms a whole group of contributors for the ISG. We have as well the international profile is clearly beyond Europe as well. We have many participants from Europe there, but we have as well Japan, Korea, Singapore, US, and so on actually as part of our members. So that is basically the way how we work. And so there's indeed lots of activities going on and interactions with ETSI between Canada and the ETSI organizations over here. And that is something over here that actually started with the ETSI QKD AG being founded in 2008. It was based on the EU project CQC. It came out of that one. That was one of the big QKD projects funded by the European Union. But at that time as well, I was already based over here in Canada. Originally, I was part of the CQC project when my research group was based in Germany. But as well, very importantly, if we think about it, Michele Mosca as well helped actually to create this ETSI ICT Quantum Safe Cryptography workshop series, and that started in 2013. So Michele Mosca as well, being here from the University of Waterloo, the Institute for Quantum Computing, it shows again that we have this interaction between Canada and ETSI. In the year 2015 as well, led out of Canada, as well with Michele, but as well Mark Peason actually helping us to make the connection to ETSI. There is a white paper on quantum safe cryptography and security that came out that as well helped to start another ISG on quantum safe cryptography over here. And I think Philippe Lafont, I think you as well part of that one, and which is now part of the TC Cyber within ETSI. So I think overall this area of quantum secure communication, both in post-quantum as well QKD, is indeed in a way already an area of intense collaboration between Canada and ETSI, right? So this one, and that means as well between Canada and the EU, right? And indeed, Michele, who speaks later on in the panel as well, is I think is really one driving forces in making these collaborations happen. Now, if we talk about basically what is that we are actually doing in our ISG, right? So then basically here is something, I think the big topics are interoperability and as well security. So interoperability means basically how to slice and dice networks that use quantum key distribution over here, so that various players in the market, QKD vendors, network applications companies, telecoms companies, and so on, how can they actually work together to really create industry-wide solutions? Then the other important part as well, we are talking about quantum key distribution networks. That means we have the underlying technology is a point-to-point QKD technology that various vendors actually are offering. And so here's important the part about security. Basically, are these point-to-point connections actually secure? That means we really talk about the part of certification of those devices, which touches implementation security, really how to evaluate those devices, how to talk about the security booster protocols, how to do authentication, and so on. Part of that one is this kind of protection, certification is, of course, as well that we have to talk about components. That means we have as well the background work, how to characterize optical components, how to characterize QKD modules, how to do penetration testing, and so on. So these are basically the activities that we're doing. And then as a third one, with vocabulary, of course, we help as well to make sure that the words over here are clear to the wider community when we use things like quantum key distributions and so on. What actually does it mean? Let me talk a little bit more first about the interoperability, because this is a very clear something which is industry driven as well by now, because we have different companies that work in different aspects of QKD networks, right? So we really need to look at this one. So the first thing is basically we start from a very pragmatic point of view, and that means we say there's point-to-point technology is today a commercial offering. And so we talk about trusted node QKD that is actually based on that technology. And we want to make sure over here, as we build trusted node technology, that we indeed can do this one, allow multiple vendors actually to operate in these networks, right? And so that means we need interoperability over here. We do not talk about interoperability between two halves of a quantum. QKD box, right? And we talk the point-to-point technology. These links that we see as the green links or the blue links over here, they would be coming from one vendor. But then actually the key processing module might actually come as well from other vendors that actually pieces together the point-to-point keys and turns this one into a network-wide application. So that is something that we are working on, these architectures. Example as well is an SDN approach, and that is probably the best approach as well to explain a little bit about where the interfaces sit. And actually, Vicente Martin is on the call and is well one of the drivers of that field. So that means we really talk about the different locations over here, where we talk about the integration about the individual areas over here, where we do interconnection in a trusted node, right? But we talk as well about how actually to get a secret key out of a point-to-point device, how to get in the node basically out into the rest of the node activity, and that are indeed our APIs for the 004 and 014 cards. That is really basically for QKD device, the interface, how to get key out of it. And that is by now really, I think, basically a success story from this collaboration, that this is a de facto standard indeed in the industry over here, right? But then basically the whole architecture over here, we really say basically how this interpretation works. I think it's as well very important, and I think that's of course even particularly important for Europe, is that when we talk about the trusted node networks, then we really have to see as well how these different networks actually mesh into each other, because we have the national border, like international borders over here, where we have different telecom operators and so on. So how do we actually provide these kind of interfaces as well? Actually, I think it's interesting as well, if you think about that one, if you talk about pre-shared symmetric key systems and as well symmetric key infrastructure overall, we'll run into similar, basically we'll use the similar kind of lines of thought over here, that we have to see basically how to interconnect these, right? Then let me, so that is basically our activity really to allow interoperability over here. And the next part is indeed a little bit security. That is now talking about the certification of QKD devices. We have actually worked on a protection profile for QKD devices, right? And so that came from an initial draft that we did, but this has been now actually evaluated by the Bundesamt für Sicherheit der Informationstechnik in Germany. That means the German Certification Authority. And that means our protection profile is now certified actually to that standard. Right. And so we are now continue as well working forward to move this one as well towards implementation security and protocol security around it, so that we really prepare the way for certification of QKD devices. Next steps will be as well to go from point-to-point technology and certification of QKD devices, really in the certification of trusted node networks, and that means as well we work as well on the key processing modules. That basically the next activity that we're doing, right? And there's a EU as well provides funding for that one. Okay, let me just give the outlook as we come to that one. It's just really for us to work together. If you think about the EU, of course, there's lots of strong activities in quantum safe cryptography. The EuroQCI is, of course, a very big activity in Europe, right? With all the national initiatives and many test beds across various countries, right? And so especially they are ground-based, but they're space-based, and the important thing as well with the view about that we have many links across borders that we expect. But if you think about Canada, of course, we have the long-standing contribution to QKD in quantum safe cryptography, like Gilles Brassard is a co-inventor of QKD, so that is a clear stance that we have. But we are international movers. I mentioned before the ETSI QKD workshop and other related ETSI activities that were actually facilitated as well from Canada. But we have as well open source project in the part of post-quantum cryptography. I would like to point out the Open Quantum Safe project that is actually founded as well by Michele Mosca, pushed forward really with a larger community adoption over here. So we have as well, and that is relevant for the certification and protocol standardization for quantum key distribution. We have as well out of my group an open platform for open QKD security that can actually help with the security analysis of practical systems. We as well have a player in the satellite-based QKD. So Thomas Jennewein leads out of IKC the KeySat satellite project. We launch actually the satellite next year. Right, and so which is as well a good complement to the activities that we've seen as well before in the previous presentation by Vicente. And as well, we have a test bed, the Nomana Kirk test bed actually in Quebec. And so that as well complements as well the networks that are coming out in the EU. And with that one, I would like to thank you for your attention. And if there are any further questions, well, you can reach out either to me, but as well, you can reach out to Martin Watt, who is actually the chair of the industry specification group. And of course, just can see online what we're doing, and as well, maybe take part in the next at the IPC Quantum Safe Cryptography Conference. Thank you very much.
Thank you very much, Dr. Norbert. Excellent presentation, and we realized what is happening in ETSI QKD, and I wish you good luck with the new technical committee that you are starting. Let's move to the next presenter because we are out of time, in fact. So now we're having together with us Philippe Lafrance, Standard Manager, and he will present the standardizing quantum technologies, the Canadian approaches and activities on standardization approaches for quantum technologies. Dear Philippe, please tell us a few things about you, and the floor is yours. Thank you.
Excellent. Thank you very much, Homer. Do we have my slides?
Yes.
Okay, well, as we get started, I'll just say good day all, welcome. It's a privilege to be here. Just by way of quick introduction, my name is Philippe Lafrance. I am the Standards Manager here at ICERA in Southern Ontario. It is also my privilege to serve as the interim chair for Quantum Industry Canada's Standards Work Group. I also am currently the vice chair of Accredited Standards Committee X9's F4 working group, so that's cybersecurity and cryptographic solutions. And very proudly, I am a member of Canada's JTC3 National Mirror Committee. And maybe I should add, formerly, I was the vice chair of ETSI Working Group QSC. So with that out of the way, let's move into the content. Next slide, please. Now, before I get into the specifics of how Canadians are engaging in this space, I wanted to set some background context because I think explicitly saying these things will be valuable for our conversation going forward. So just a couple of claims here. Claim one is, of course, that the global standards ecosystem is this very deeply complex thing. It is interconnected and it is very nuanced. And relatedly, the claim two is that if we want to optimize the way that we engage in standards and the impact that our standards ultimately have, then fundamentally we need to understand and embrace this claim. So next slide, please. Now, Vicente went over some of this, which is nice, but when I think of the global standards ecosystem, I think of it as a many-bodied problem because there are many bodies involved. It's not just the SDOs, there are a bunch of other bodies involved. So on the SDO side, we of course have the domestic, regional, and international standards bodies, but we also have industry groups, we have consortia, and we have governments involved. And with all these different bodies, we have all these different types of relationships between them. So be it liaison agreements, memoranda of understanding, or the Vienna-Frankfurt agreements, things like that. Or you might even have normative dependencies between deliverables. So you can have one body over here that maintains a standard that has normative references to a document maintained by an entirely different group. So what this means is we have all of these different bodies or all these different structures of different scales all over the world with all sorts of different types of relationships between them. So it really makes this globally complex web. Next slide, please. And that's not the only source of complexity here. There's also the diversity of the participants. Within a regular standards group, you're going to find things like governments and different agencies from those governments, academia and nonprofits, private firms, and that's going to mean everything from small startups to large multinational organizations. And depending on the body, you might also see consumer groups or individuals participating in their own capacity. And a consequence of this diversity of participants is a diversity of perspectives in the room. So each of these players are going to have their own motivation, their own goals, their own background, their own reason for participating in this body. The result of that being that these standards bodies can be very heterogeneous, which I'll just blanketly say in general is a very good thing. Next slide, please. So here's a little bit of a fun question. How do standards get developed? And the answer is ultimately it comes through the consensus building process. These participants come together and they agree and say, aha, yes, there is value in producing this standard or passing this deliverable. So they vote to support it, and depending on the body, their voice of support might mean committing resources to its development. But I just said we've got all of these different perspectives in the room. So this means then that by nature, to build this consensus, you're incurring trade-offs. So you're going to have to talk to the different stakeholders. You're going to have that open dialogue. And in some cases, you're going to have to compromise on what you're working on, which again, I think ultimately makes these deliverables better. Let's say that. Next slide, please. Okay, and the last little background context I want to say is this phenomenon I refer to as the butterfly effect of standardization. And by this, I just mean when a standard is published and goes out into the wild, it can have second order, third order, and higher order impacts. So it might have these impacts to those dependent SDOs or other related bodies I just mentioned, or it might have these cascading impacts through supply chains, the broader ecosystems, or even related sectors. Which is why I like to say that a good standard strategy, insofar as it is feasible, recognizing there's practical constraints here, but insofar as it's feasible, a strategy will try to anticipate these higher order impacts and incorporate that input and opinions from the broader stakeholders, with the ultimate goal there being to reduce the adoption friction. So reduce that friction so that you maximize the proliferation and adoption of the standards and the related technologies. Okay, so that's the context I wanted to set up. Next, I'm going to go into what Canadians are actually doing in this space, but I want to caveat this with, of course, I don't have perfect insight into everything every Canadian is doing, but my goal is to show you that this is a relatively comprehensive and multifaceted approach, even though in some aspects it might still be maturing. But next slide, please. So this, go back one. I just skipped two. Sorry. So this first slide is all about PQC and quantum networks. So we have the core algorithms and the primitives. So working in bodies like NIST or NCCOE, heavy Canadian involvement in developing these core PQC algorithms, the related primitives, and looking at things like implementation, crypto agility guidance, transition guidance, and things like that. But then by nature, we have to move up the technology stack and we have to say, okay, how do these things fit into our mission critical communication protocols, let's say TLS or IPsec? So now we're looking at bodies like the IETF, CFRG, or OASIS Open. And again, for years, very heavy Canadian involvement in these things, looking at how do we update our syntax and our encodings to make sure it's all interoperable and can properly use these new algorithms. And the last one on this slide is all about ICT and quantum networks, and we just heard a good amount about this from Norbert. But now we're looking at ETSI ITUT or the IEEE SA. So defining PQC usage in these different ICT applications, looking at, again, adoption, quirks for implementing particular algorithm families, migration frameworks, and that sort of thing. And then on the quantum networking side, it's like we just heard, the requirements and guidance relating to QKD protocols, security, interfaces, network architecture, and all that. And very, very nice stuff. So really, really good work out of those bodies. Next slide, please. But that's, of course, not the full picture. We also have to consider the global norms. And here I'm going to very specifically focus on JTC3. Because Canada has a very active and engaged National Mirror Committee for JTC3, and I'm very happy to see very high caliber experts being deeply engaged in this. Currently, we are participating in almost all of the working groups and ad hoc groups and so on in the committee. I think there is a single exception at the moment. But of course, this is still very early days. So as the group continues to mature and the education and awareness goes out, we're expecting to certainly increase this engagement. But so far, it's a very active, very engaged group doing some very good things. So I also want to mention Quantum Industry Canada, so QIC, Canada's industry consortium. So QIC is very focused on making sure that they understand the needs of the Canadian quantum tech stakeholders more broadly, understanding their voices and their opinions, and making sure these things are properly facilitated to the entities that need to hear them. So be it the standards bodies, policy authorities, and so on. So on the standard side, some of this is still early days, but some really good trajectory for the stuff here. Next slide, please. And I'd be remiss if I didn't mention Canada's National Quantum Strategy. In particular, Canada's NQS maintains roadmaps. And these roadmaps very explicitly support standardization efforts. And this includes the certification and the validation efforts, which I hope we all agree are of paramount importance when it comes to these topics. And the last one I want to mention here is the Canadian Forum for Digital Infrastructure Resilience. Now, in particular, they have a quantum readiness working group. And this group develops these best practices for making critical infrastructure quantum ready. And one thing that I, in particular, really appreciate about the work this group is doing, in particular, recently there was a joint report they put out with Europol's Quantum Safe Financial Forum and the US FSISAC. And they very clearly understand this problem of the global interconnections I mentioned earlier. So especially for financial services systems, it's a global thing. So it's not enough for a regional entity or ecosystem to start migrating. That can still create bottlenecks if there's other laggards and things like that. So I think there's some very good insights coming out of that group. So I just want to give my appreciation to them. Now, before I move on, I want to just take a moment and talk about Canada's priorities in this space. Now, again, with the caveat that I can't formally speak for Canada, but I can give you my perspective based on my experience here. And so what I would say is fundamentally Canada's priority is to ensure that the right structures are in place and that the right education and awareness raising is done. And second to that is ensuring that the right foundational guiding technical documents are in place. So the documents that we're going to be building up on over time. We're not necessarily in a rush to do technical specifications or international standards, although in some cases that is certainly appropriate. The goal is to make sure that we're setting things up right now for success in the future, because it's a very long-term thing. Maybe phrased differently, the goal is to avoid technical debt. So next slide, please. We're almost done. Now, before I close off, I just want to give some of my opinions about ways that we can productively collaborate going forward. So just very quickly, the first one is just consensus amongst ourselves. So just dialogue, communication, engaging and identifying the stakeholders here. We talked about gap analyses, and I like the idea of impact analyses on standards, and I think that's something we can talk about. Pre-building consensus. So technical reports are great, survey documents are great, but let's not bring proposals to these formal bodies. They're effectively novel research. So let's pre-build consensus amongst ourselves. This is what we think the best practices should be, and then bring that for a formal proposal. And finally, very near and dear to my heart, is recognizing that standardization is in and of itself an art and a science. And so let's leverage this fact. Let's take lessons learned from approaching standards in other domains and see how can we use this to maximize our approach and our impact here. So next slide, please. And I regret I'm slightly over time on that. So thank you very much for your time and attention. I am still Philip LaFrance, and I'm looking forward to the rest of the conversation today. Thank you.
Thank you very much. The key messages at the end were excellent. Thank you very much. Just a short question. Okay, you promoted and you suggested dialogue between EU and Canada, but we need a platform in order to have this dialogue. You believe that entities like SDOs are the appropriate platforms for that, or entities
I think
like KIC or Quick, etc.? Yeah.
I think it's a tiered approach. SDOs is a very, very formal approach. My intuition is to go through the industry consortia for starting. So there's already relationships between Quick and QIC, but let's increase that. I think once Quantum Industry Canada, so we have our standards working group, and we're looking to more formally scope it and figure out exactly what we want to do with it. But once that's in place, I think it'd be a really good vehicle for having Canada's stakeholders communicate more with the European stakeholders. And like I was saying, do that stakeholder engagement and just have that informal, moderately formal dialogue before we go to these formal SDOs, recognizing that we can walk and chew gum at the same time. We can also use the SDOs, but it's sort of that twofold tiered approach would be my intuition.
It's very clear. Thank you very much. Okay, let's move to the next speaker who will present QBC's mission and activities. The industry engagement, standards alignment in quantum technologies is David Morquente, coming from QUIC. David, the floor is yours. Please.
Okay.
Yeah.
Hello. First of all, thank you for letting me speak on behalf of QUIC. I'm David Morquende. But I don't know if my slides are on there, but it would be nice to have them. You also see me in moderating a panel at the end of the session. But now I'm going to talk about QUIC. So next slide, please. So this is me, David Morquende, and next slide, this one. So what is QUIC? So QUIC is the European Quantum Industry Consortium. We have just listened to Philip talk about QIC, about the Canadian Quantum Industry Consortium. So in Europe, we have also QUIC. QUIC is a non-profit member-based association established back in 2021. And the main mission of QUIC is to grow and strengthen the quantum technology industry and position Europe as a global leader of the sector, with a big focus on the industry, because we are an industry-based and industry-led association. So mostly 70% of our members are for like industry, for companies. So from the SMEs to the large enterprise. We not only look at the industry, because we also need RTOs, academia, investors, VC, etc. So the idea of QUIC is to serve as a collaboration hub. If we go to the next slide, please. We can see like there are many actors. In fact, we have, well, I believe that now we have 215 members, and we are pan-European. So it means that to become a member, you have to be in Europe geographically. But that's not all. So we also welcome what we call affiliates, that are companies whose headquarters is in Europe, but they have a presence, like an office and people working here or something like that. So if in this case for Canadian companies, if they have any kind of presence in Europe, they can also join somehow QUIC. So following with that, if you can get the next slide, I want to talk about the QBC that we will see in the title, that is the QUIC Business Community. So the purpose of that is to have Europe and the global stage and the collaboration with other countries. And as at Europe, like a good meeting point for all the quantum industry matters, with a powerful voice on the quantum industry. So that's why we have members, affiliates, and we welcome everyone to join to talk about quantum. So on the international landscape, and you can next to the next slide, there are several things that we are doing and Europe is doing, and we will see a little bit about the strategy and what QUIC has to do with it. So first of all, we are founding members of ICQA, the International Council of Quantum Industry Association. In this body, we have a partnership with QETC in the States, with QIC in Canada. We just have heard about them, and QStar in Japan. And that's not the only thing that we are doing. Specifically on standards, we are also part of the high-level forum of European standardizations. That is a body that talks about the standard within Europe, really tied to the Commission. But also we are present in several other sites, like the Sensenelec GTC22. Some of our members are also present in the ISO EIC GTC3, and also ETSI and many others. So if we talk about the strategy itself, about the European quantum strategy that was presented on the 2nd of July of this year, there are several points that talks about the standards and the relationship with other countries and how can we like foster those relationships. So first of all, we have a point about the interoperability of the standards that we have to ensure that the new quantum industry has cross-platform compatibility, and also that for the next year we'll have to publish the European Quantum Standard Roadmap. So we have here other speakers talking about this kind of roadmaps, and I believe next year is going to be a good year to align about what are the roadmap for the different parts of the world. Also, in international positioning. So we have, of course, the European strategy has to talk about European presence and the strength of Europe presence, but also it talks about the collaboration in the international forums, trade dialogues, and multilateral quantum alliance. So there is plenty of work to do here. And also about certification and security framework. So we have the project like EuroQCI, also projects like the Quantum Internet and etc. So we have to foster this kind of certification frameworks in order to be able to collaborate and actually make projects. But that's what the strategy says. If you go to the next slide, we have also published a position paper about this strategy. What are the thoughts of the industry? What are the thoughts of our members? And you can find in the QR code the actual position paper. So you can to the next slide. I have here some examples about the things that are in this document from like the IP, the standards, the benchmark, and then we will be seeing like a slide with the cross like recommendations that we have or the thoughts that we have, and then one slide for several topics like the communication, computing, benchmarking, etc. So a good way to start this is like with like the IP strategy and the standard roadmap. So we have to incentivize the industry to join these different standard bodies because, we can set up standards, but if the industry is not involved, they will never work, to say that. So if we go to the next slide, I have represented here the roadmap that I have already talked about, but the main idea is that everything has to be technically interoperable. So first of all, with the certification and the security frameworks, with the schemes that can lead to clarity in this kind of processes. Also, the standards that we will be talking about or that we are right now thinking about must to be pragmatic. So if we cannot implement this kind of standards or if it's too difficult, the industry will suffer from that and will like take some time into adopting this. So that could be a problem. And of course, the global position. So how the EU industry will align with the different countries and parts of the world. In this case, like for example, with Canada, and that's why we have this kind of agreements. If you go to the next slide about quantum communications, so the test beds are really, really important in order to be able to test different technologies across the different industries and also in the research. The QKD certifications, the EuroQCI integration that I think that we will be talking more about it in the panel, and the timeline pressure, of course, like we have to test everything, we have to set up these standards, but also we have to do it in time and manner. So we have to also have that in mind. If you go to the next slide, we can see like for sensing in the development of standards in the EU strategy, we are talking about, of course, in the roadmap, the gravimeter deployment, and that we need to define clear testing infrastructure for collaboration, compliance, and integration with this classical system. In computing and simulation, you go to the next slide, about benchmarks and metrics and cloud access for these quantum services. So we have seen that we have several companies that already have cloud access to the quantum cloud, and we have to foster that, but with some kind of cross services. If you go to the next slide, we have something about also chips and space and defense with clear point about the dual use and the standardization in space. the free space communications and how this will affect the standards and how the standards will affect the nowadays projects. With that, I want to conclude with the last slide, saying that standardization is a strategic enabler. It's not something optional that we can avoid, and that the roadmap and the standards that we are doing should be inclusive, aligned, and it has to have some forward-looking, because this kind of coordination will ensure that the collaboration that we have with other partners will lead to a successful landscape. Thank you.
Thank you, David. Thanks that you have identified the key points that are as challenges for the future. Following what Philippe said, he believes that the industry, KIC and QUIC, other industrial entities should initiate this dialogue and should facilitate this dialogue. So with your QBC initiative, you intend to facilitate this dialogue between Canada and EU, and of course generate some conclusions or whatever, and send and inform the stakeholders accordingly.
Yeah, of course, and not,
yeah, please.
Yeah, I mean, like not only with like that. So as being connected with the industry, we can leverage the different bodies. In this case, for example, or the Commission or the high-level forum or the Census Elect at some point with the GTC 22, because we are listening to what our members are saying. So that can foster the collaboration with other countries, for example, Canada. And we have like the ICQA, in which we have these kind of forums for fostering the collaboration. So yeah, for sure.
Yes, it's obvious, and that your role is key in this dialogue. Thank you very much. Thank you very much. Let's go to the next speaker, which is Quasem Rifat, and he will give us an overview of what is happening in ISO IC JTC3, because a lot of interesting things are happening there. So, Dr. Quasem, the floor is yours. Thank you.
Okay. Thank you. Hi, everyone. It's a pleasure to be here. I'm a member of Structures Quantum Wave Group and an associate to Nexus for Quantum Technologies Institute, and also a research associate at the University of Ottawa, a member of JTC Canadian Mirror Committee, and also its former chair. Here, what I'm going to talk is my own idea. It does not represent official position of any institute. It should be understood as my academic freedom given to me through my academic association. I was going to talk about JTC, what is going to happen, what is happening in JTC3, but I believe that Philippe covered it very nicely. So I'm going to propose a couple of ideas here that we could work together. Quantum standardization is not a narrow technical exercise. It is a constitutional moment for global technology governance. The framework we set today in quantum technologies, either in IEC, ISO, and or National Mirror Committee, it determines not only technical interoperability, but also the ethical and geopolitical architecture of the next half-century. Once those architectures harden, inclusiveness becomes almost impossible to retrofit. This early phase is our only real opportunity to embed fairness, openness, and balance into the DNA of quantum technologies. Today, much of the momentum is led by industry alliances and consortia. Their technical contributions Their technical contributions are vital, but governance risks of concentrations are clear. If the voices shaping quantum standards comes only from industry, the framework will optimize for market, not for societies. It will serve efficiency, but not necessarily legitimacy. And legitimacy, as we have seen in AI, is the cornerstone of public trust. Once lost, nearly impossible to rebuild. Canada and Europe are ideally positioned to co-lead a new standardization model, one that balances openness with strategic coordination. We share a common foundation, a belief that innovation must serve people, not the other way around. Our system value pluralism, democracy, and evidence-based policy, and we already collaborate through initiatives like Horizon Europe, NSERC partnership, and the EU-Canada Digital Partnership. So how can we translate this shared philosophy into action? Let me propose two practical steps, low-cost, high-impact interventions that we can start today. Step one, build informal cross-committee networks in mirror committees between mirror committees in Europe and Canada. Today, many non-industry stakeholders, including academies, policymakers, civil society organizations, lack agile forums to influence pro-standardization work technologies. We don't need new institute. We need better connections among the ones we already have. Imagine 3 informal cross-committee networks that reach participants in JTC3 with their counterparts in national mirror committees across Canada and Europe. Stream academic networks that aligns terminology, testing protocols, and referencing metrics before they reach the formal drafting stage. The second one, for governmental coordination, a lightweight exchange on post-quantum migration, procurement standards, and data sovereignty, and so on. And the last one, civil society channels that opens dialogues with NGOs and ethics institutes to ensure equity and human rights safeguards are embedded early. These conversations would not replace formal mechanisms, they would humanize and accelerate them, empowering coherence long before votes are cast. Second step that I'm going to propose is to reflect on inclusiveness in JTC strategic plan. The strategic plan of JTC3 currently disappropriately emphasizes on industry, and it falls short to reflect ESO's multi-stakeholders principle. Canada and Europe could lead an update to that effect. This approach also aligns perfectly with EU standardization strategy set in 2022, which calls for a value-based, inclusive model of standardizations, one that supports democratic governance and trust in technology. My colleagues, we have solid foundations to build on. Canada's national strategy calls for multi-stakeholders engagements. Europe's quantum flagships embed ethical and societal reflection directly in its roadmap, and G7 leaders NASC's vision recognizes quantum as a shared democratic priority. The scaffolding is already here. What we need is a sustained dialogue and common intent. Let me highlight that quantum is not just a new layer of physics. It represents a new layer of human coordinations, a new social contract about how we handle uncertainty, information, and power. If we embed inclusiveness now in technical, ethical, and institutional DNA, quantum technology can become a model of responsible innovation. But if exclusivity takes root, we will recreate the same fractures that currently hinders AI governance today around the world. We can, my colleagues, we can construct informal coordination mechanism across partners for academia, NGO, and governments that are already present in JTC3 without contradicting any rules. We can rewrite strategic plans of JTC3 to empower the position of academia in NGO and governments. Okay. The beauty of this moment is that it is still formative. The committees are young, the definitions are fluid, and we still have the freedom to design the rules of the game. But the window of the game is short, but it is still open. Let's use it together. Let's design a quantum future that reflects our shared democratic values, coherent, equitable, and globally trusted. That, I believe, is the true quantum leap ahead of us. Thank you.
Thank you for sharing your ideas. We have noted them, and for sure we will build on them. Really interesting thoughts. Thank you very much. Let's move to the next presenters, Fabian Steinlechner and Thomas Genevine, who will present us a real use case of cooperation between EU and Canada. They will present us the hyperspace initiative. So, Dr. Fabian and Dr. Thomas, the floor is yours. Thank you.
Yeah. Hi, thank you very much. Thanks for having us. I'll just introduce myself. I'm Thomas Genevine. I'm a professor at or adjunct professor at Waterloo University, and in particular involved in space-based quantum communication. And Norbert already mentioned the Canadian KeySat mission that I have the honor of leading, and very excited about that. But today, together with Fabian Steinlechner, we're going to talk about a joint initiative that we've been working on as a European-Canadian funded project, which actually involves various institutions on both sides of the Atlantic, so to say, in Canada and Europe. And so let me just, oh, sorry, next slide, please. Thanks. So the motivation of this project that we called Hyperspace is to establish or investigate how to establish entanglement across the Atlantic between a station in Europe and in Canada. But in particular, we want to focus on the elements of utilizing hyperentanglement as a means to improve the channel efficiency by either using higher dimensional quantum states or also multiplexed quantum states. So that's maybe the core idea. It is a very low TRL project because a lot of these questions are still pure scientific in nature. So the overall activity of the project was to investigate the hardware that's needed and the systems that needed and the science and even just protocols. But but we also set out to, so next slide, please. We set out to investigate the mission scenarios that could be looked at. So that's in particular what my team at Waterloo was doing. So we investigated different ground station locations in Canada and Europe, and looked at a lot of different satellite orbits that could be, suitable. So next slide, please. And in particular, so we analyzed many different scenarios, and in particular, we identified that given some constraints we set ourselves in terms of ground station size and other parameters, the most likely scenarios are multi-node scenarios to make this happen. Realistically, either 3 satellites, so a 3-node scenario is the most likely one, 3 satellites in trailing orbits or in side-by-side orbits. A very interesting scenario might be involving high-altitude platforms as 2 of the nodes. And so we looked at various different scenarios and identified the 3 that we're showing here as the most likely candidates. I won't go into more detail, so maybe we're just going to the next slide. So, and when looking into more detail, what it means is we're breaking down the scenarios that we selected into the technologies, the core technologies that are needed, like the telescope, the tracking, the quantum sources, the quantum analyzers, and all of the various other schemes that are required, and we're identifying a lot of the challenges around this. And when it comes to considerations of interoperability in particular, which is, I guess, the theme for today, is the questions we encounter, and which are still not clear to us even in this project, is what are the optical wavelengths, what is the protocol that is going to be used, the photon encoding. We looked at various options, and that still has to be defined. Device performance that are required, right? And methods and approaches of multiplexing or / utilizing the higher dimensionality of the quantum states. And another really big item is how to do the synchronization between the various nodes that are used. So these are some of the core questions we're still trying to answer. So they will be needed for standardization, of course, but we're not quite there yet. Maybe next slide. And I think that's going to be the end of my portion. So as one of the last activities we're doing in the last few months of this project, the project will end in March 26, is looking at the various technologies that we have within the consortium, but also beyond. This includes quantum light sources, broadband, multiplexed quantum channels, manipulation of the quantum states and the analysis, and also using adaptive optics for space links. Those are some of the examples of technologies we're now putting together into a technology roadmap where we want to identify which technologies, how far they are advanced at the moment, how much more advancement is needed, and this will be a pathway to define how such a mission could be implemented. And with that, I'd like to hand over to Fabian.
Right.
Next
Thank
slide.
you. Thank you, Thomas. So then, maybe also just briefly introduce myself. I'm Fabian Steinigner. I am a professor for quantum information technology at the Friedrich Schiller University in Jena and head of the Photonic Quantum Systems Department at Fraunhofer IOF, where, we're part of the Hyperspace Consortium. And now that Thomas has given you sort of the broad overview, I would like to pinpoint some of the discussion topics that we've been having, like aligning our understanding of what certain metrics mean. So next slide, please. We're developing a lot of technology at a very low TRL level that should enable these entanglement-based quantum communication or entanglement distribution in this extremely high loss scenario. And we've been within the consortium, we have many different technological platforms and approaches on how to generate these entangled photons. So waveguide-based micro-ring resonator sources that produce entanglement, fiber-based sources, and then the bulk optics approaches. And yeah, I guess when it comes to the topic of interoperability, hardware and devices like this source, one key parameter is to be one key factor is to agree on certain performance metrics and definitions. And we'd set out the goal in hyperspace to demonstrate an entanglement source capable of providing 1 billion photon pairs per second emission rate. And what we found, at an early point in the discussions, is that all the different communities, people from different fields of approaches in quantum light sources, have very different definitions. And so some related technical discussion points were like, where in the system is it inside the source, or at which fiber output is this pair rate actually even defined? What spectral properties is it tied to? So how big is the wavelength bandwidth over which these photons are emitted? Are we talking about the emission over a single WDM channel or many WDM channels? How much power does this device consume? So what's the pump power that you need to send into the system to achieve that pair rate, which is of course a very relevant requirement in the space context? And then are there any trade-offs with other performance metrics like the quantum bit error rate or the state fidelity? And it was very interesting to arrive at a set of like common definitions now for something that seemed for each of these individual communities of source engineers a very well-defined and almost trivial question. So next slide, please. Another technical point where we have our work essentially cut out for us in terms of agreeing on definitions is the topic of encoding the quantum states. So polarization and time bin as binary degrees of freedom are kind of well established, but in hyperspace, we're considering combinations of these degrees of freedom and how they can be extended to higher dimensional systems, like not just using time bin qubits early and late, but many of those time bins, and also how we can use the frequency degree of freedom to encode additional quantum information. Because essentially what we found is in this long distance link scenario that the key rates will be very, very limited. And so we need to kind of control and use all these degrees of freedom in a smart way to arrive at a link budget that can give us some positive key rates. And so our goals here are to just demonstrate the feasibility of transmitting these types of encodings over free space links. We have a series of test beds set up for that. So what you see here on the picture is a test bed in Jena, but there are similar test beds in Padua or in Canada, where we're looking into how well these new encoding formats for quantum information are transmitted over free space links. And why we're interested in that is because these higher dimensional systems promise higher noise resilience against certain types of noise. And against there we've had intensive discussions about which degree of freedom is better, because these noise mechanisms depend very much on which degree of freedom you're technically using, and discussions on how the Q-bar requirements that you set out depend on the dimensionality or the size of your alphabet in your encoding. So all of these points where simple definitions like Q-bar are being tied to degrees of freedom, types of protocols, have led us to arrive at a better understanding of the pros and cons of different degrees of freedom, but still a lot of work to be done. So with that, next slide, please. Another key topic is, even though this project is now still working at a very low TRL, we're also thinking about what it means in terms of requirements for infrastructure on ground, in particular optical ground stations. And so we've had a lot of discussions, like Thomas mentioned, about wavelengths and so on. And well, one sort of activity that has been also inspiring in that regard is this OGS requirements, so sort of an example of the specifications of optical ground stations that would like to connect with the Saga mission should fulfill. So this is, I understand, also now very much connected to the EuroQCI initiative, where these requirements are now being will be adopted by several ground stations across Europe, and this can give sort of an idea of discussion points, important discussion points towards standardization. And so again, in hyperspace, we're not quite there yet that we can formulate such detailed specifications onto the low TRL. But at the end of the day, I think we will be having many more discussions on these different specifications, and hopefully arrive at a toned down version of requirements so that we can move forward. Yeah, next slide, please. So all this we've been discussing in hyperspace has been primarily focused on entanglement distribution and the perspective of quantum key distribution, but we're very much aware of this perspective of applications beyond QKD. And so I guess that just shows that the level of discussion we've already been having to arrive at common understanding of parameters will be amplified manifold when we look at applications that even go beyond entanglement distribution and QKD. So there's a lot of reason to engage in technical collaboration across the transatlantic as a first step towards defining such standards for quantum communication applications beyond QKD. And with that, I look forward to your discussions. One last slide. So maybe just the wrap up, and maybe Thomas would also like to kind of at the end complement this with a few things, but it's a summary of the hyperspace. So we've been evaluating a number of different communication approaches or architectures in how such a entanglement distribution link might be possible. Our understanding right now is that this will require new ways of encoding high dimensional quantum states and multiplexing them, and really trying to max out on the information transfer on the photonic quantum link. And a whole array of basic scientific questions still remain before we can approach standardization issues on this topic. So we're still very much at low TRL, and I guess a lot of more work will be needed, in particular on agreeing on basic performance matrices and defining channel properties that go beyond polarization or time bin qubits to general high dimensional encodings. And yeah, so with that, thank you very much for your attention. And Thomas, do you want to have something? Do you have something to add? All right.
Here, thank you very much. Yeah.
Thank you for the presentation. Very interesting. It's an example. It's a best case scenario. Two research groups from Canada and the EU are participating. My understanding is that you are having a dedicated work package 5 where you intend to develop a document. You call it technology development roadmap for sources, links, interfaces, etc. This document will be public or it's confidential? The first question is this.
No, that's a really good question. No, the intention is to publish a paper about this mission scenario and the technologies. That is the intent.
Okay, and since you are working together and you are exchanging ideas, expertise, etc., and you intend to develop these papers and this roadmap, etc., how you intend to utilize this effort you are doing? I mean, do you intend to contribute to an SDO? There are many roadmaps in EU now. EU is going to develop a roadmap for quantum communication, quantum technologies next year. Sensenelec also intends to update its own roadmap. Do you intend to allocate some resources to this, at least Sensenelec or other groups, to provide some of your expertise in these SDOs?
Maybe excellent question. So right now, I mean, yeah, you're right, and Thomas also mentioned the project is ending beginning next year, and we're looking for ways to find a new platform to continue this collaboration, either so at the same time on the technical aspects, but also on the more blue sky research topics of an intercontinental quantum network for applications beyond the QKD. So we're in the process of finding ways to continue this very productive collaboration, and as it approaches more higher technical TRL levels, I think definitely to contribute to such activities makes a lot of sense.
Okay, that's a good sign that you will intend to continue the collaboration beyond the project. That's a good thing. I mean, this shows a very productive cooperation between you. Thank you very much. Let's move to the last but not least group, the business case for post-quantum security, the industry perspective, where David Morkente will moderate the group. David, please introduce the panelists. The floor is yours.
All right, thank you.
Thank you very much.
Thank you, Homer. So good afternoon. I'm David again. I have just presented about QUIC, the European Quantum Industry Consortium. So it's a pleasure to moderate today's panel about the business case for post-quantum security, industry perspectives on the value of quantum-ready security. As quantum technologies evolve rapidly, both Europe and Canada face a strategic question. How do we secure our digital infrastructure before quantum computers make today's cryptography obsolete? So today I have a wonderful panel of leading experts that I'm going to introduce. So first, Michele Mosca, co-founder, president, and CEO of Evolution Q, and professor at the Institute for Quantum Computing in Waterloo. Eleni Diamanti, co-founder and scientific advisor of WeLink, a French startup pioneering quantum network interconnections, and Johanna Sepulveda, senior expert on quantum secure communication at Airbus, represented the perspective of a large industrial integrator. So for today's panel, Michele will start with a short framing presentation on why quantum-ready security matters now, and how EU-Canada collaboration can turn this challenge into economic opportunity. After that, we will have a panel in which I'm gonna ask maybe difficult questions to our panelists. So Michele, please.
Thank you very much. Bonjour tout le monde. Buon pomeriggio. Will the slides be shared from your end, David? Okay, perfect. Next slide. Yeah, just a quick level set. Just a slight step back and to reflect on how we got here, where we are today. From ancient times, when we were trying to encrypt, communications and information, we manually exchanged keys, used symmetric key methods. And that's more or less what we've been doing until the late 80s, early 90s. Of course, when the internet came along and offered this great opportunity, we couldn't really seize it unless we secured it. And that aligned with the advent of public key cryptography. And the important thing is we didn't standardize public key cryptography because standards bodies thought it was a cool idea. banks and governments needed it, and that created a pull for the standardization and deployment of public key methods. It was an enabler of the last 30 years of economic growth because it allowed us to have a secure internet, not a resilient one, not a cryptographically resilient one, but at least it was secure against what we knew. And new methods evolved actually even in the 80s, but didn't really become product grade and deployed, at least in some systems, until the 2000s. Quantum key exchange, which allows us to, in some sense, instead of physically securing the data or relying on a trapdoor predicate assumption, to give us another way to exchange keys. Now, cryptography, as I said in one of my remarks earlier, I come from the mathematics part. Of course, back in the 90s, when I was in my 20s, I thought, well, my part's the most interesting and important part. The rest, how hard could that be? You eventually realize, okay, the infrastructures in which these things are deployed, secure implementation, interoperability, and so on is very important too for these to be practically used. So we evolved, again, for centuries, millennia, symmetric key infrastructures, where somehow you got this key, you use it to encrypt and so on. Public key infrastructure was a great enabler. It does require more work. You now have to compute your key through this authentic channel, also authenticated usually by PKI. And there's pros and cons. And most systems today that either they have no protection, they use either a PKI type solution or an SKI type solution. You create PKI using both public key algorithms and symmetric key algorithms. SKI traditionally relied on out-of-band pre-shared keys and symmetric key cryptography, but you can actually leverage and deploy public key capabilities there too. This is kind of the backdrop. Along comes, next slide, Shor's algorithm. And okay, we have a bit of a problem with the public key infrastructure. The other two infrastructures are more or less fine, but we do have to rapidly, by rapidly we mean in 40 years, update our public key infrastructures. Next slide. And I think one thing in terms of seizing this opportunity, we have to, the market forces work fine if there's no externality, right? If there's an externality, don't pretend the market forces are going to work. And I think one externality is we kind of just, this cryptographic risk, this cryptographic 0-day thing, we roughly approximate it as 0. That's a big, problem because there's an infinite distance between 0 and epsilon when you take the inverse function, right? So we got to stop approximating cryptographic risk as 0. And when we do give it some epsilon, it's not an additive epsilon. It amplifies vendor concentration risk. It amplifies supply chain risk, right? The Ukrainians, I was at a defense event a few days ago. They're like, we can't rely just on one GPS vendor, right? We need at least 3. Well, if they're using the same cryptography and the cryptography is broken, you still have a hyper concentration risk and so on. And it's not just what secrets, it's really affecting operational capacity and resilience. And the consequences, especially in the world of hybrid war, can be a lot more than some PII fines, right? It's really a potential existential threat. So we have to properly assess this risk, not bring it down to 0, but bring it down to something acceptable. Next slide. Right, and why do we really need to properly manage cryptographic risk and not just leave it as something for the technical people down in the trenches? Like, we really have to properly, explicitly ask for what's our readiness level for cryptographic 0-day. I'm not expecting perfection, but that we at least take existential threat off the table, or at least to a 1 in 10,000 risk, like other existential threats. Why do we worry about this now and not before? Well, for one, quantum computing is on our doorstep. We're getting hundreds of logical qubits on the order of 5 years or less. That's uncomfortably close to cryptographic relevance. Regulators are starting to play a role in internalizing this externality and kind of forcing us to be cryptographically resilient, at least against the known threat. That's not enough. It's necessary, but not enough. With AI turning vulnerabilities into exploits and then scaling the exploits and also potentially crippling other defenses we have rapidly, our risk tolerance for cryptographic vulnerabilities is clearly going down. We need to be more ready, and we're also realizing that cryptographic migration is not easy. It's complex. It can take many years. It's not something you'll be able to. You'll have zero chance of dealing this if it's a 0 day, and you haven't prepared. So that's kind of the backdrop of why we really have to get much better ahead of these cryptographic 0 days. Next slide. And this fits inside, we keep hearing about the word resilience again and again and again for very obvious reasons, including obviously the war in the Ukraine and others, and other, hybrid attacks and so on. We dealt with this with endpoint authentication. There, the market forces, it was becoming problematic when we were just password only. We knew how to fix it, right? It's not perfect, we know, but it works. You can get cyber insurance now if you have MFA. If you don't, you won't. And you won't. If you don't use it, you won't be covered. But two distinct, diversity, right? Defense in depth, risk-based. You don't do it everywhere, right? PNT. Again, the Ukrainians are like, we need at least 3 GPS vendors, but we're also working on non-GPS approaches, modernized old school GPS, position, navigation, timing. And that's another part of the quantum agenda. And the way to achieve cryptographic resilience is, again, there's only so many ways to do this. And it's clear when you step back and look at it. It's modernizing public key infrastructures with PQC, right? Hybrid and other techniques, and modernizing the symmetric key infrastructures. These are very complementary approaches. It's not a religious debate. These are just, sane design choices. We generally know when we want a PKI or an SKI type solution, or maybe both. New IETF standards allow, like TLS 1.3, to both grab a pre-shared key. Again, the beauty of SKI is it does the grunt work out of band, right? And there's pros and cons to that. But you have for systems where you really want to reduce your risk, you can actually do both, right? So you leverage the properties of both. You wouldn't do that everywhere, probably, but having these two systems available is really critical to be able to really confidently go out there and seize all the wonderful quantum computing and
I
AI
have to stop
opportunities.
you, Michele, because you're
That's
stealing
good.
all my questions.
Yeah, okay. So I think I'm done. Yeah.
I think that you said a really good baseline about what we will be talking about today. So for the panel, I have thinking about the questions I'm gonna ask and so on. So I think that we will cover part of business, technology and standards, and the relation with EU and Canada. So first, maybe to Eleni, because Michele has shown about how cryptographic risks amplify other risks. And from the perspective of WeLink and the broader quantum networking ecosystem, what market signals are you seeing? Are customers already asking for this kind of quantum-ready capabilities?
So thank you very much, David. Thank you very much to Instar for the invitation to the fellow panelists. So then thanks to Michele for setting the stage as well for this discussion. So maybe I should also say that in addition to being co-founder and scientific advisor of WeLink, which is in this capacity that I'm participating today, I'm also an academic researcher that has worked for many years in quantum cryptography and communications at Sorbonne University in CNRS. So yes, so to ask your question, David, I think there is a business interest. I guess this is your question on the issue of quantum safe communication. I think Michele has explained very clearly what should be looking for in this space. And the way that I can see this growing is through the different verticals where this is actually becomes an important issue. So in particular, space and defense, and I guess Joanna will have even larger intuitions than me on this space. But also more globally, if you are looking into interconnection of quantum computers and long distance quantum communication, which is the space where WeLink is situated. this context. So maybe we can talk, so I guess it's a little bit of a lower context. I guess we need to grow the quantum networking as a business itself, which is an enabling technology for pushing to quantum safe communication.
Yeah, I think that's the case. But we have to foster all of the network in order to make the actual network. So you take upon a really good point about the security, about the defense, dual use. So maybe for Joanna, as you mentioned her, so Airbus operates like in a highly regulated and highly security critical environments. From the aerospace and defense standpoint, what is how do you like, what is your approach to this? What is the important thing that makes the investment or the post-quantum security inevitable?
Correct. First of all, good afternoon, and thank you for the invitation. It's a pleasure to be here and speaking about this relevant issue, and also in the cooperation between Canada and you. It's a pleasure. So for us, I think the case of Airbus is very exciting, I would say, and very challenging in the sense that we are users of security. So that means that our own infrastructure has to be protected, but we are also security suppliers, so at different levels and certification levels. So we have this kind of user, civil and defense perspective. So it was clear, and I think also due to the different task of the discussion about the risk of the quantum computer, it is clear from us and for the customers that a transition to quantum secure capabilities is mandatory. So this is not an option. And for that, there were already several preparation in place. So we, for example, we know that the first layer and the first like technology that can be or must be rapidly adopted is the post-quantum crypto, and for certain applications that require high levels of security will be an additional layer of quantum communication. So for that, we start in, for example, as user, we start for doing since several years ago, we create an internal group that is in charge of the crypto inventory, in which we identify where are the assets that must be protected and how we can transfer to or migrate to post-quantum cryptography. That it will be the first one. And also all the needs in terms of requirements on performance, but also on a standard and certification, because we need to use secure solutions, but we also, to our customer, we have to provide things that can be certified, that can keep the certification and the security level that we initially submit. So it is, I think, a very, very challenging part, but we already are following these steps towards the different migration. We have different customers that have already very tight deadlines of migrating by 2030 quantum secure. So this is something that it is challenging for the industry perspective.
That's right. It's great to hear that you have several customers that need to do this switch, and very fast, even though that certification point or the standardization point is still well, in a difficult situation, let's say. So as we are having this kind of customers or the industries is starting to adopt this, question to Michele, that I know that you are working with financial, with telecom sector, with many sectors. So as these new customers or customers are adopting this, where do you see that the strongest business case is emerging for these solutions, given though that maybe the certification on the standard part is still lacking?
Or which solutions, like, PQC upgrades, or actually adopting symmetric key methods and quantum enabled cryptography?
So
Because they're kind of different.
Yeah, so I will say starting with the PQC, but with a more focus of the next quantum safe solution. So briefly about PQC, like super fast, and then to the actual next stage.
Well, the PQC is mostly being driven by upcoming regulations, right? So obviously providers to governments, they have to provide PQC. Nobody cares what you think. If you don't provide it, we're not buying your stuff. And that obviously sends a signal. Financials, the regulators, FCA just had a meeting. So regulation between compliance and security, compliance wins 110% of the time. So the fact that, this is going to be a license to do business is that you're PQC compliant. A small handful of more forward-leading institutions, they're starting to get ahead. NIST is also, and others are saying you need to be agile. So there's a few leaders who are starting to think of since we're doing all this work anyway, what should we be doing to minimize our future upgrade costs, right? And be a little more ready. So there are a few who are looking at modern, alternative symmetric key alternatives and even quantum-enabled cryptographic functionalities. But it's absolutely critical that government as a customer, just like it did with PQC, starts articulating we also need to be ready for cryptographic 0-day. And then we technology people can figure out how to layer in proper defense in depth, symmetric key methods, and quantum networks, or as an augmentation of symmetric key infrastructure. So you need government as a customer, and then the regulated sectors. Because we give them the option to not be resilient and let someone else, if I can gamble with someone else's money, my risk decisions are going to be very different than if I'm actually responsible for the risk decisions I make. So it's absolutely imperative that, PQC migration is not a genius insight anymore. You're not a visionary or a leader by requiring PQC migration by a deadline. That's like survival. Like that is 10, 20 years ago, that was visionary. 10 years ago, maybe. Like now that's survival. It's really cryptographic resilience. And if we don't do it, all this capability we're creating with quantum networks and inventing PQC algorithms and whatever is, again, free R&D for China and the US and other people to commercialize. We have to become proactive users of these technologies, but in a principled way. So let's just properly manage cryptographic risk, and then there'll be a pull for all these great technologies that we're creating.
Yeah, I really like how you say about the investment and how the ecosystem will be different if you will invest with your money or with someone else's money. It's so funny. So talking about that, and actually we are talking about the different use cases and the applicability, maybe to Eleni. So how, because you have this knowledge, so how close we are actually to achieve this scalable entanglement distribution across networks, maybe also taking upon the EU-Canada collaboration that we have, the for free space or satellite experiments.
Yes, of course. So it was nicely described as well in some of the previous talks. So there has been a big push in Europe with a EuroQCI initiative for terrestrial projects, terrestrial quantum communication infrastructures. At the moment, they remain mostly prepare and measure type, just to put this a little bit in a small framework. But there is within the next phase of the European strategy, there is an initiative to push more towards quantum, the next generation of quantum networks with entanglement distribution at large scales. And in parallel, we're developing in Europe a lot the satellite communication with, in particular, a big new bunch of projects that are starting now for the Connecting Europe facility outcome. Okay, so we're expecting that this model of connecting national quantum networks via satellites, but also quantum repeater-like entanglement distribution networks will advance a lot in Europe. And of course, companies like ours play a major role in these initiatives, like Airbus as well, and of course all the major players industrial in the field are involved. So I think we're getting along in Europe very well. We do not have, as you know, of course, yet the so-called quantum repeater, but this is advancing well, and the objective is by 2030 to be able to advance this technology. I think, and we've seen already with, in particular, with the initiative, the hyperspace initiative that was presented just before, that Canada is also a leader in this field. So maybe we can discuss about this later with, in particular, very developed satellite space-based solutions. So I think for me, it will be an obvious, field of collaboration in this space, and I think this will also help pushing the business strategies behind the quantum safe solutions, because it removes essentially some of the barriers that are on the way today for adoption for some players, not all of them, obviously. So having different generations of frameworks for quantum communication will be very useful for business cases, I believe.
Thank you. Yeah, like completely agree. And I want to know also if Michele or Johanna has something to say from the perspective for the integrators, for the hybrid classical quantum infrastructure. Maybe Johanna more on the part of the aerospace or satellite, but feel free to.
Yes, so currently they have different initiatives, and I think in both sides, as we saw in the different presentations here in Canada, but as well in Europe. I think there is a huge concern for building the infrastructures. So it is good because both parties have again several experience during the last years on really the deployment of this technology. For the business case, it is important that the customers start to see the realization of this kind of technologies, quantum secure technologies, both post-quantum and quantum in a hybrid way. And many of our customers also prefer in a hybrid way, in case that if something gets rotten, you at least have a layer of protection. I see a lot of potential for collaboration because currently, and this is as Eleni was discussing, one of the next generation infrastructure will be the main concern will be the cross-domain communication, and for this cross-domain it requires a lot of interoperability. And for that, for example, standards are super relevant. We saw that we have different initiatives of developing optical ground stations. We want that these optical ground stations can, for example, receive signals from different kind of satellites with different kind of encoding. So we need to define interface, and not only in the space part, but also in this liaison between space and terrestrial segment. We need to make this cross-domain also standards to enable the adoption of this wide technology and terrestrial. I think one of the major challenges is as QKD, for example, it is a focus on the high levels of security, and that is the promise. We need a very strong certification as well. So it is good that we now have the test beds. In Europe, we have the security test beds, and that will enable to certify, to explore the security of the different components and do more protection profiles in which we can adopt this technology faster.
Yeah, so if we are talking about standards and interoperability and all of this stuff, maybe Michele, can you like give some light about how the companies actually can collaborate in or participate in the global standardizations or collaborate between them? I don't know how this like standardization thing can come from the actual companies.
Yeah, well, Phil LaFrance did a great job summarizing this, but it's really critical that it's being driven by the end user and the vendors, industry driven. We've done a lot kind of pushing that rope and getting it ready from the more research side, but we need industry to really lead. And I think part of a successful quantum strategy, a strategy about, including quantum safe cryptography, is to make sure the companies have resources to participate in the standards efforts. Otherwise, those who do put the resources in there's a risk of hijacking, the rules of the game, which can very seriously undermine our ability to protect, create resilient infrastructures, right, and trust them. And I'm not suggesting we try to rig it either, but I think we need just to make sure we have enough of people from Canada and the EU who are aligned in terms of we want a fair, level playing field that is optimized for, aggressive value creation because we trust our infrastructures. But it's hard because a lot of our, we have SMEs. It's rather, it's an expensive cost, and we need to make sure we're on a level playing field in terms of being able to bring our people to the table. Because some jurisdictions, they're bringing a lot of people to these standards bodies, and I think we need to make sure there's Canadians and Europeans who we trust are transparent, really driving the necessary standards we need and making sure they're not sort of unduly steering things in a direction that doesn't help us.
Yeah. So on this point, so the industry has a voice, of course, but also from maybe Eleni or Joanna, maybe Eleni, that is more that has been more close to the research part. How can we avoid that, as Ms. Eleni said, some industry part or some company try to overrule the standards and put their standards in front of others, or the research part, or to say something that maybe for the short term for the company or the industry is good, but on the long term that could be an issue.
Okay, so I think what needs to happen at both EU and Canada level is to work all together, including all stakeholders, from researchers, academic researchers, from experts to the industry, to end users. I'm really very much in favor of doing this type of observatories that has been proposed recently for quantum safe transition, including all the players in its field, including the experts. And I think where the academic researchers can help a lot is to help setting the benchmarks. It has been said before, and I'd like to emphasize this a lot, in key performance indicators for quantum networking in the general sense, for quantum safe communication and cryptography as well. More globally, I think we're still lacking into this, despite all the efforts that have been done in the various fora. And we saw a little bit in the previous presentations that ETSI has been working for a while, that there is actually, I think there is no, for the moment, generally acknowledged and accepted by all stakeholder benchmarks and KPIs that will lead to the standards with appropriate work are still missing. And this is where the input of the academia is very important. And this will avoid the effect for me that you just described about industries, like some industries hijacking the standards.
So we still have a couple of minutes remaining. So I have kind of two last questions for all of you, actually. I know that Joanna said at some point that they have like deadlines that they have to achieve for their customers. But for you, what would be a realistic roadmap for all of these post-quantum and QKD networks to be actually implemented? I don't mean only in Europe focus, but also in connection to other countries like Canada and so on.
So if you want to see my wish list,
okay, your wish list, let's say.
It will be more like a bet. The thing is that if the customer already set a deadline, we better be in that deadline, and it is 2030 that is the start to have that. So I think it's something that we have to achieve now. For that, it is important that we onboard and we are working together with the suppliers, so to work together in order to be able to integrate all these capabilities as integrators, and that is why for us it is very important the role of the standards that currently we we need to really integrate all the community, all discussing together, and that is good that currently they are starting to align all the standardization bodies so that we don't have duplication of work, but we can advance as soon as possible into this part of integration and interoperability, and that counts for post-quantum and for QKD. Standards also is very relevant to boost this technology adoption, because we need the standards to create our products. Otherwise, it will be a high risk to create a product that when no the standards are there. And also these kind of standards enable the development of an open market, and that we have different suppliers and somehow they are competing. That is good because it keeps engaged and the suppliers and offering good capabilities. So my wish list is that we met this deadline, 2030. Some of the customers are also sometimes more relaxed, 2035, but it's clear that we have to act now. And sometimes these, and I think everybody can agree here that the migration of effort is being underestimated. It is a huge task that we have now to speed up.
Okay, thank you. So as we are running out of time, let me ask a final question for you, like maybe starting with Michele, then Eleni, and finally Joanna. Talking about wishes, if you could like have a wish for the short time, like maybe next year, about a real win-win for both EU and Canada collaboration, what will that be?
I think within 12 months, we can have a harmonized, because we're doing all these cryptographic inventories, understanding our cryptographic risk, because we ignored that, dealing with RSA being broken. But all that visibility, all those inventories, you can then say, well, what if MLChem is broken? What if this is broken? And you can correlate that to enterprise risk, national risk, right? We've done all this work now. So all we need to do now is collectively articulate our risk tolerances for different sectors, because it's the same. It's not like we're less worried about our financial sector collapsing than France or Germany. So for the main regulated sectors, we have similar risk tolerances. So let's collectively decide what is an acceptable risk tolerance for this for the top 2 or 3. Don't eat the whole elephant. Pick 1 or 2 critical systems, harmonize risk tolerance, and then a harmonized timeline for having sufficient defense in depth and so on, so the risk is acceptable. Assuming, because we have to be ready for even the PQC algorithms being broken, and then leverage in the short term classical symmetric key infrastructures or whatever other mean. We don't prescribe the solution, but obviously that's part of the solution, right? And then over time, quantum networks will be actually a better way to provide that cryptographic defense in depth. But articulating the resilience requirements, that can be standardized or uniformized and coordinated across Canada and the EU, because we have similar risk tolerance, and the timelines similar to the PQC timelines. Like it's going to be similar dates, but we first have to articulate the desire to be resilient.
Thank you. To you, Eleni?
Yes, so within 12 months from now, Canada will have joined the EuroQCI with a specific plan I mean, so that we can connect some way through our satellite program, the Canadians, both satellite programs, the Canadian networks that are currently running. We will have agreed on a specific collaboration agreement under the European Quantum Act that will come live, as you know, in 2026, and we're working on it with specific roadmaps, including in quantum communication. So Canada will be a privileged partner in all these aspects, and we will have, in particular for quantum safe and transition, we will have agreed on a specific set of benchmark as well, KPIs, which kind of goes to where Michele says, and in a common horizon for this transition.
Thank you. Remember that this is recorded, so we will see later if this is everything true, because it's my wish list too. So finally, Johanna.
Thank you so much. They are very ambitious like targets, and I like it. We have to be ambitious, and I think I would like to see already at least a first demonstration of interoperability between the two countries of some quantum secure networks.
Okay, thank you so much. So I think that with this, we can conclude this wonderful panel. I want to thank again our wonderful speakers. And back to you, Homer.
Yes, thank you. Very interesting discussion, very interesting insights. Thank you all, David, for moderating that, and for the panelists. We are having together with us Paul Quilin from DG Connect, European Commission, and Carlos Lopez Rodriguez from European Commission as well. And maybe they want to comment and complement what we have discussed until now. The floor is yours. I think you have the right to discuss and comment on what we have heard from the industrial session we had here. Pauline and Paul or Carlos, please.
Yes, thank you, Homer. Thank you, colleagues. So first of all, thank you very much for the organization again of this excellent session today and the two previous days in IoT and data. We took a lot of interesting notes from the experiences from industry, and we look forward to receive the, let's say, the conclusions or the report with the conclusions from Minstar. But maybe I was not able to participate in all the webinars, in all the sessions, but I think our head of unit, Olivier Branger, at the beginning of the week, he mentioned why standardization is important for these three key areas that we were discussing during the week: IoT, kind of opening markets, ensuring interoperability of different solutions, etc., etc. Data, we have in the digital partnership agreement with Canada, facilitate data-free flow of trust, or also cooperation on interoperability of data spaces or standardization is really key to achieve those ambitions. And in quantum, which is really, really key topic or a hot topic in technology now. I mean, it's in the last 3 weeks, I think I've been in 3 events related to quantum here in Brussels. Is super important for the competitiveness of our industry, and it was very interesting actually the reflections on the round table, how to facilitate participation by industry, because in standardization is, as we all know, is a contribution-driven exercise. So industry should have the incentives to participate and also the means. So it is important to facilitate their participation, and also this can be done by a more cohesive system. So trying to coordinate between the different SDOs and agree on which topics are taken by each one, because what we don't want is duplication of effort, and that the experts are forced to choose between different places because they don't have time necessarily to participate in all the different standardization activities. So yes, I think in this case is very important, all these things. So from our side, it's really appreciated these workshops that we have organized this week with the support of our Canadian friends. So yes, reiterate that we are looking forward to receive the conclusions, and the idea is to discuss them at government level, and potentially bring some of these very important points from industry into the political discussions that will take place later this year in the Digital Partnership Council. I don't know, Paul, maybe you want to complement, but I give you the floor. So thank you very much from my side.
No, not to add really much, but just thanks again to Homer for facilitating this session, and for the other colleagues from the INSTAR project who facilitate the others, and of course to our Canadian colleagues for all their participation. So, and maybe just to ask the, anybody who has proposals for what we could do next at a practical level, pragmatic level, to let, for this session, to let Homer know. I think he has the slides anyway, but some very good reflections there from a colleague who spoke from, I think, his notes, which I think were a lot of very good inputs there. So, if people can provide their summaries of what they propose as practical next steps, including from the last panel and the other panels, and provide them to Homer and the colleagues from the INSTAR project, they will then be able to compile that, and we can then reflect on them internally here. And again, if any of our Canadian colleagues want to contact again through INSTAR or directly to Carlos and or myself, we're happy to get your inputs on the next practical steps. Yeah.
Thank you. Let's keep the discussion going then, in order to keep both regions at the forefront of this quantum safe innovation. Again, once more, thank you all, the presenters, for the insights, for the valuable insights. As you said, Paul, we will build on this and we will try to highlight the key points, and we will send you these key points to you. We have noted everything, we have recorded anything, and we will start working on this content. Thank you all. We are out of time, so wish you all a great rest of the day, at least the Canadian, here is night. So thank you all. Thank you very much. Okay. Bye.
Thank you, everybody. Thank you. Thanks, Homer.
Thank you. Bye-bye.